Hi everybody, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week, we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. So, before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem ADA and dishes, which is a cakewalk problem. And let us see the agenda for today. So first we will understand the problem statement as usual. Then we will understand the concept by which we can solve the problem. Then we'll see a quick summary and then we'll also see the code, and probably this time we'll solve it on the CodeChef IDE. But before we rush to the problem statement, let me share some great news with you. Did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic related to competitive programming? We have beginner level courses like Introduction to C++ and Java, basic data structures. We also have advanced level courses like greedy problems, recursion, and advanced data structures, problems on graphs and trees. These courses are taught by the top coding experts who are IOI medalists, ICPC World finalists, and have worked in top product-based companies like Apple, Microsoft, Google, LinkedIn, Flipkart, and so on. So all you need to do is download the Unacademy app or register yourself on unacademy.com and choose your goal as competitive programming. You can also take the paid plus subscription to get additional benefits and individual level support. We have a large set of practice problems associated with every topic related to competitive programming. Also, we have 6-star and 7-star teaching assistants who will take up your doubts during the session and after the live session. So, you can use my referral code to subscribe to Unacademy. Use Prachi16 as the referral code and get 10% instant discount. So what are you waiting for? Hurry and start your competitive coding journey today. The problem statement says that we are given n number of dishes that we have to cook, and we are also given the preparing time of each of the dishes, which is given as here CI minutes. So these minutes are given for the cooking time of each of the dishes. So as you can see, I have written it already in an array form here. If we are given 4 dishes, then these are the timings which each dish will take to cook, like 1 minute, 3 minute, 2 minute, and 4 minute. Now what we need to do is that we are given 2 identical burners in our kitchen and we have to cook these dishes on those 2 identical burners. And we need to find out the minimum time which is needed to prepare all the dishes and prepare them completely using these 2 burners only. Now, some important things that are given in related to these 2 burners are that first thing is we cannot remove the dish from the burner until and unless it is cooked completely. So what does that mean? That if any dish takes 3 minutes to cook, then for total of 3 minutes it has to be placed on the burner. We cannot remove it before 3 minutes. The second thing that is given is that no 2 dishes may be on the same burner at the same time. So definitely that you also know kitchen rules, right? So on the same burner there can never be 2 dishes. Now the third thing that is given is that suppose like at 5 minutes, some dish is prepared at t equals to 5. Now you need to remove that dish and put some other dish to be cooked. So at t equals to 5 only you will remove that dish and put another dish. There will be no time wasted, like no extra time is required to remove the dish and then start cooking another dish. So that is also something that you have to keep in mind. Now, we have to find the minimum time needed to prepare the dishes. So how can we do that? Think of a way such that we can minimize the time that all the dishes will take to prepare. And remember that we have two identical burners which we can use. So we are given these two burners in which we have to place the dishes and cook them. So what are the possibilities that can be there of placing the dishes on both the burners? So the first possibility can be that we use only one burner to cook all the dishes. But definitely that will not give us the minimum time, because see, if we place all these dishes, all four dishes on the same burner, so it will take 4 plus 3 plus 2 plus 1 time, which will be equals to 10 minutes, and this will not be minimum. So definitely this possibility is removed. Now the second possibility is that we place one of the dishes on burner 1 and rest all other dishes are cooked on another burner. So yes, this can be a possibility, but not always, right? So from all of these dishes, suppose we place dish 1 on burner 1 and we place all other dishes on burner 2. That means 3, 2 and 4. These are the minutes, 3, 2 and 4 minutes. These minutes will be counted on burner 2, and on burner 1 only one dish is put, which takes 1 minute to cook. So finally, how much time will be required to cook all the dishes? So definitely we cannot take 1 minute, because on burner 2 there are still some dishes left which require more time to be cooked. So we will have to take the upper bound, because we have to make sure that all the dishes are cooked completely. So that is why we will have to take the time which is maximum out of the two. So 3 plus 2 plus 4, which will be equals to 9 minutes. And likewise, even if we place dish 4, which takes 4 minutes to cook, the maximum time to cook, on burner 1, and we place the rest all other dishes on burner 2, that is 1, 3 and 2. So then also 3 plus 2 plus 1, it gives us 6. 3 plus 2 plus 1 will give us 6 minutes. So 6 minutes is also not the minimum time that will be required to cook all these dishes. So yes, this possibility is also removed, because it will not always be true. It may be true at some point of time, but not always. Okay, now the third possibility is that we use both the burners by dividing the time appropriately. So what does that mean? That we have two burners and we have to make sure that the dishes that we are placing on both the burners is such that the time is divided equally on burner 1 and burner 2. Only then we will be able to find out the upper bound that is required to cook all the dishes completely. So how can we do that? So now let's divide the dishes on burner 1 and burner 2 according to the order given here, 1, 3, 2 and 4. Now dish 1 takes 1 minute to cook. Let us place it on burner 1. It takes 1 minute to cook. We have placed dish 1 here. Now burner 2, we will place the second dish. So it takes 3 minutes to cook. Now we come to dish 3, which takes 2 minutes to cook. Now you can see that on burner 2 there is some dish cooking, but on burner 1, after 1 minute the dish will have cooked, dish 1 will have cooked, and no other dish is placed here. So definitely we will have to place dish 3 on burner 1 and not on burner 2, because if we place dish 3 on burner 2, suppose if we place it here, and it takes 2 minutes to cook, so it will be 3 plus 2 5 minutes unnecessarily. And on burner 1 there are no dishes cooking, but still we have not used that opportunity of placing the dish here, so definitely we will place it here. Now we have this last dish which will decide that which of the where we should place it such that we get minimum time. But are we actually going to get minimum time? Let us see. So now both of these burners are at 3 minutes. So we can place dish 4 on any of the two burners. Let's place it on burner 2. So it will go up to 7. dish 4 is placed here, which takes 4 minutes to cook. But can you see that the total time that all the dishes will be required to cook is taking 7 minutes here. 3 plus 4, 7 minutes. We will have to take the upper bound, as I already told you, because even if on burner 1 there are no dishes cooking, but on burner 2 there are still some dish cooking. So we have to make sure that all the dishes are cooked. Only then we can say that yes, this is the minimum time which will be required. So it will take a total of 7 minutes, but we have already established that 7 minutes is not the minimum time, because 6 was not the minimum time, so obviously 7 is also not the minimum time. So why did that happen? We took the dishes and placed them in the order that was given to us on the burners, but still we could not get our minimum time. Why? Because we have to make sure that on the burners we place those dishes first which takes maximum time. So if we do that, then we would have ensured that at least those many minutes are being used up and they are not left for afterwards, they are not left for the end. So if we ensure that, then at last we will always be able to find out the minimum time. So let us check with that example now. So we have here dish 4 which takes the maximum time to cook in all of the dishes. So we will place that dish on any one of the burners. Let's place it on burner 2. It takes 4 minutes to cook, dish 4. Now we will place the second highest dish, second highest time taken by the dish. So that is dish 2. Dish 2 takes 3 minutes to cook. Now we cannot place it on burner 1. Again, why? Because on burner 2 we have an empty burner. So why not place it on burner 2, right? So let's place dish 2 on burner 2, which takes 3 minutes to cook. Now we have this dish 3, which is the third highest dish. Dish 3 takes 2 minutes to cook. Now where should we place it? On burner 1 or burner 2? So definitely we cannot place it on burner 1 because it is taking 4 minutes. The dish which is already placed on burner 1 is taking 4 minutes to cook. Whereas in burner 2, the dish which is placed here is taking just 3 minutes to cook. So after 3 minutes, it will become again empty. So we have to ensure that it does not remain empty unnecessarily, because we have to minimize the time, right? So we will place our dish 3 here on burner 2, and it is taking 2 minutes to cook. Okay. Now we have just one dish left, that is dish 1. Now where should we place it? On burner 1 or burner 2? So if we place it on burner 2, then we will increase our time, which is not required. We will increase our time to 6, which will again not be the minimum time, because on burner 1 you can see that there is after 4 minutes the burner 1 will become empty, because dish 4 would have been cooked after 4 minutes. But on burner 2, till 5 minutes we have no vacancy. Till 5 minutes burner 2 will be occupied. So we will place dish 1 on burner 1, which takes 1 minute to cook. Now as you can see, on both burner 1 and burner 2, the time which the dishes take to cook is 5 minutes each. So here our answer will be 5, which is the minimum time required to cook all the dishes. So as you can see that we have equalized the time of burner 1 and burner 2. And even if there is some scenario where you see that on burner 1 and burner 2 the timings are not equal, if you see that scenario, then also no problem. We will take the upper bound in that case. So let me show you an example. If suppose instead of dish 4 took 5 minutes to cook, instead of 4 minutes it took 5 minutes to cook. Now let us see. We'll place the dish with maximum time on one of the burners. So we will place it on burner 1. Now we'll place the second highest dish on the burner which is empty. So we'll place it on burner 2, that is dish 2. Now we have the third highest dish as 2 minutes, taking time 2 minutes. So we will place it on that burner which has some vacancy left. Like here it is occupied till 5 minutes, but on burner 2 it is only occupied till 3 minutes. So after 3 minutes it will be vacant. So we will place the dish here. That is dish 3, right? Now we have just one dish left and we can place it on any one of the burners. So let's place it on burner 1. It doesn't make a difference wherever we place it. So we have placed dish 1 here. So in this case, our answer will be 6 minutes. That is the minimum time required to cook all the dishes. So I hope that I am very clear that we have to always choose the maximum timing dish and place it on the burners. And if we do that, then we will ensure that at the end we will not have those dishes left out to increase our time. We can minimize the time in that way. Now talking about the input, output and constraints. So as usual, input, the first line will be the number of test cases. Then for each test case, we'll be given the number of dishes n, and we'll be given the time which is required to prepare all the dishes in the second line. So that is a space separated integers. Now the output will be, we just have to print a single line of output, a single integer which tells us the minimum number of minutes required to prepare all the dishes. The constraints, so for the test cases the upper limit is 1000, and for the number of dishes given to us the maximum can only be 4, which is very less, very small. And the timing that is required to prepare the dishes, so it can be maximum 5 minutes for any particular dish. So as you can see, the constraints are very small. So our greedy approach, that is always taking the maximum dish first, will work in this case because the constraints are very small. So let us discuss a quick summary of how we are going to solve our problem. The first thing that we will be required to do is that we have to sort the array that is given to us, which contains the time of preparation of each of the dishes. And why are we sorting that? Because we always have to pick the maximum dish first. So if we are given an array of 4, 3, 1 and 2, then we will sort it in reverse order, that is 4, 3, 2 and 1. So it will make it simple for us to pick the maximum dish first. Okay. Now the second step will be to take two variables. One for B1 we will take for burner 1 and B2 variable will be for burner 2, and we will initialize both these variables with 0 because initially both the burners are vacant and no dish is being cooked on them. The third step will be that now we will run a loop and we will check each time that out of burner 1 and burner 2 which one is at minimum time. So whichever will be at minimum time, we will accumulate the time required for any of the dish to be prepared in that burner. So if suppose like burner 1 is at 0 and here burner 2 is also at 0, so we can use any. So suppose we are using this dish with 4 minutes. So 0 plus 4 will be equals to 4. So suppose B1 will contain 4 now. Now next time when B1 is 4 and B2 is still 0, so for the next dish the accumulation will happen for B2 because B2 is minimum. So that way we are going to solve our problem. Now the final step will be our answer, which will be maximum of burner 1 or burner 2. Why maximum? Because I told you that we have to take the upper bound always in order to ensure that all the dishes are being cooked, because we have to find the minimum time required to cook all the dishes. Okay guys, so now let us code in Python. First few lines are for the inputs. First line is for the number of test cases. Then we have run a loop to ensure that we encounter each test case. For each test case, we have the input for the number of dishes and for the time required to cook each dish. Now, what we'll have to do is for burner 1 and burner 2, we'll initialize two variables, B1 with 0 and B2 with 0. And now we will sort this time array, which contains the time which is required to prepare the dishes. So we'll sort this. We'll sort this here, c.sort, and reverse equals to true. Reverse means that it will get sorted in descending order. That means the highest time dish will be in the starting and the lowest time dish will be present at the end. And why are we doing that? Because we have to, in our code, we have to use that dish first which has the maximum time. So now after this, we will run a loop so that for each of the dishes, for picking up each of the dishes, for I in range. So there are n dishes, right? So we'll run a loop up to n from 0 to less than n. Now, what we have to check is that out of burner 1 or burner 2, which one is minimum. So whichever will be minimum, the dish will get added in that burner. So we'll put a condition here that if B1 is less than B2, then in that case, we will accumulate the dish timing in B1. So B1 plus equals to C of I. It means B1 equals to B1 plus C of I. That means at ith position, whichever dish timing is present will get added in burner 1. But else, that means if B2 is less than B1 or B1 and B2 are equal, then in that case, we will accumulate it in burner 2. So the same thing we have to do. Okay. Now, after following these two steps, our work here is done. This will automatically give us the answer in either B1 or B2. So we require the minimum time required to prepare all the dishes. So that is why we will have to take the upper bound, because we need that all the dishes should be prepared. So we will have to take the upper bound between B1 and B2. And for that, our answer will be maximum of B1, B2. Right. So this is going to be our answer. And at last, what we just need to do is print our answer. Now let us submit this code and see that if it is correct or not. So we have submitted the code and waiting. Hope this is the correct answer. Great guys, we have solved our question and this is our answer. So now if you understood the concept, then please do like this video and also make it a practice to submit the video even after the contest is over, because if you will submit this question, then it will enhance your coding practice. And if you have any doubts, then please post it in the comment section below. We are there to help you.